Can you see my screen?
Yeah, I can.
Okay, so in this time here you can see this is the one kind of Sentinel-5 satellite imagery. So basically from this Sentinel-5 satellite imagery we can easily observe the different types of gases. So as you can see ozone, then nitrogen dioxide, sulfur dioxide, formaldehyde, then the methane, carbon monoxide. So all of you can see carbon monoxide. Okay, so this type of gases we can easily access using the Sentinel-5 satellite imagery. Okay, Sentinel-5 satellite imagery we can easily access all of those gases, and from here we can easily get the different time period for the time series chart or temporal analysis about the carbon monoxide or methane or formaldehyde, sulfur dioxide. All of those gases we can easily get from the Sentinel-5. So it is the one way, and this carbon monoxide for overall all of those things, suppose fossil fuels or car driving, so all of those including for that biomass burning, all of those things we can monitor. This is the one kind of carbon monoxide. So it's a one product of the carbon. So if you want, you can also use it, this data for Sentinel-5. Or another, if you want, you can also use it as suppose carbon storage for specific trees. Suppose carbon storage for suppose forest. So in this time here you can see this is the another thing is that, so mainly, okay, just I simply open the one link. So storing the carbon dioxide with the geological sequestration. So this is the another way. Suppose you want to identify for any specific forest or any specific trees for their photosynthesis, how much carbon dioxide they are used. So it's the another things. So basically two things we can easily get from here. One is for that, suppose if you want, you can also use here the Sentinel-5, and you can easily get this type of things. Suppose carbon monoxide, then methane, formaldehyde, or if you want, suppose for a specific forest or a specific trees, how much carbon dioxide they are used for their photosynthetics. So if you want, you can also use it, monitor this type of things. Okay.
Okay, and what do you think it's gonna be better for a refinery?
Okay, so in this time, what your specific object on this study area? Is
Okay,
it
so basically the
urban
refinery
or
produce.
yeah?
Okay, so basically the refinery produce jet fuel, naphtha, kerosene, diesel, and these kind of
Yeah.
products.
So I think in this time for that you can use it this Sentinel-5 satellite imagery, and for that kerosene or diesel. So this type of things mainly it's one kind of the fossil fuels. Okay, it is the fossil fuel, so that's why I think we can also get the better result when you can use here the Sentinel-5 satellite imagery to trace this type of gases, and using this data set you can easily make the concentration map. Suppose this region is the high density of the carbon monoxide, this region is the low density of the carbon monoxide. So this type of things you can easily get it from using the Sentinel-5 from the carbon monoxide.
And
Yeah.
and can we say that you can maybe use like in the blend process, you know, that's like naphtha, kerosene, diesel, they usually blend specific components together to come up with a refined product.
Yes.
So can we predict like if you're gonna use those components, it will produce less carbon than those two and so on?
Yeah, if you're going to do it, no problem. Yeah, if it's possible to do that. Suppose, okay, let me check you some result from the Art Engine platform. Just very simply open a data set. Suppose Sentinel. L5. And from here, we can easily get type of things carbon monoxide. Let's just open these things.
And is it like using a specific formula, like a chemical formula to calculate the carbon emissions, or just like an algorithm in AI?
So in this time it's
Like I'm
a
talking about.
algorithm, and in this time this satellite image you can see in this time this is that offline carbon monoxide emission, and its dataset provided mainly is the European Union Copernicus. Okay, and this is the time period about this dataset. So basically, this is the one kind of dataset. This dataset provide you the high resolution imagery of carbon monoxide concentration for the different time period. We can easily get from here. And carbon monoxide is the important. You can see there the stress trace gas for understanding the tropospheric chemistry. And main source of the carbon dioxide is the consumption of the fossil fuels, biomass burning, okay, atmospheric oxidation, methane for other hydrocarbons. Okay, so basically in this time diesel or other types of kerosene is one kind of the hydrocarbon. Okay, so that's why I think we can easily trace using this data set for the specific boundary, and we can easily get make the concentration map. As well as from here we are also generating the time series chart for the temporal time series chart. From this temporal time series chart we can also use it as the prediction, such as a 6 month, 2 month, 4 month, anyone we can easily do it for the time series. You can see here we can easily get this unit is the mole per meter square. Per meter square, how much mole carbon monoxide gas is available? We can easily get this is the unit about our density map. We can easily get from here. So in this time here, this is the map about that is a demo code about that. I'll show you that, and it's show and it's a global data set. We can easily get the global map for that concentration of the carbon monoxide. So you can see it show look like these things. Yeah, you can see.
So yeah, it's already calculated like the carbon emission.
Yes. In this time, we can get this type of map, and here the red color, it show about that high concentration of carbon monoxide, and black color identify about the very low. Okay. In this time, you can see this type of region is the high carbon monoxide consumption. It show for the whole world. Okay, global. We can easily get from here. And if you want to check, suppose click on here, you can get some data set. What is the condition about that? What is the value for the specific coordinate? We can get for this coordinate 0.0457 mole. Okay, click on here. We can get 0.049 mole carbon monoxide concentration. Okay, so now we can easily import it our specific boundary, and further we can easily make this produce this carbon monoxide map as for our specific time period, as well as we can also make the time series chart for checking the temporal analysis, when it will be high, when it will be low. So these type of things we can easily produce from this data set.
And like in terms of time, what do you think that we need to like have a prototype for this project? And when I say prototype, we don't care about the accuracy because we have like a short time. So
Yeah,
for the accuracy,
for the accuracy,
the must.
Yeah, if you have any ground truth data, then it's also better to make the accuracy. So basically in this time, suppose here you can say I can get the for a specific location, I take the value, this type of value. You also check for the specific location from the ground. Okay, from the ground you check what is the value for the carbon monoxide. Okay, then we are use here the RMC method, mainly root mean square method, and then calculate the accuracy of our map, which I can get from the satellite.
Okay, and the thing that my concern, like if they're gonna ask what's the formula, like the chemical formula, what things that you multiply or divide by to have the carbon emission.
Okay, so in
So
this
do we have
time,
like a clear formula for that? Like because this project will be presented to chemical people and as a proponent. So basically, okay, if you're gonna show them the map, for sure they're gonna be impressed. But they're gonna ask about their field, like in chemical way, what things that you calculate or what things that this is my concern.
yeah, okay. So for that, in this time, I think they are also apply the some in this data set. When you can click, suppose I show you the all of those things about that. You can see in this time there use here the convert tool using this bean special operation, and source data is filtered the remove pixel QA values. Then okay, so 75% of the tropospheric carbon dioxide column number density band of nitrogen dioxide, 50% of all the data set except the ozone and sulfur dioxide. Okay, and we also get the more information about this data set. Okay, so carbon density validate. Okay, I can create example about that. Okay, and click the more information. So now we can get that TROPOMI, the data product carbon monoxide. The TROPOMI carbon monoxide is the column's 5-day average center of the 5th December. Okay, so it is a 5-day average about this data set, and it is a carbon monoxide. The TROPOMI carbon monoxide, mainly daily global abundance of the carbon monoxide in clear sky, 220 megaspectral range, and okay, so clear sky observation. Okay, so cloudy atmospheric. So basically, this is the method, okay, for creating this, making this data set for the TROPOMI carbon monoxide about that.
Okay, so so I think it's clear for me. Just to summarize it, that we're gonna have the solution to have a satellite image for refinery, calculate the carbon,
Yeah.
predict which component will produce lower carbon than the other, and then forecast the emission of carbon for the next like 3 years,
Yes.
4 years, whatever, according to historical data. So
Yes.
are we clear now?
Yeah.
Yeah, now let's just move to the next part, which is like the time, and also as a freelancer, for sure, you're gonna have like specific cost for that. So, what's
Yeah.
your estimation for this?
Okay, so in this time, your project mainly you want to make the concentration map for carbon monoxide, as well as make the time series chart, and then also forecast for the 6 month or 4 month. Okay.
Let's say that for if we can have it for a years, maybe it will be better for them.
Yeah, I think.
Like if we can.
Yeah. Okay, so
Because I told you, like they told us, like clear, we don't care about the accuracy. Just give us something that work, and we can scale it up later.
Yeah. Yeah. So for that prediction, in this time, you want to predict the concentration map or predict only for the time series chart. Which one you need? Suppose,
Sorry,
yeah.
could
So
you repeat?
yeah. So in this time, do you want to make the time series chart for prediction or make the predict for the land use, for suppose concentration map? Which one?
I didn't get your
Okay,
question.
so
Sorry.
okay. So one thing is that suppose you can see, I just show you a time series chart. Um, Suppose here you can see it's the example about the time series chart. So here you can see the average monthly weather analysis. So it's a one kind of time series chart. So in this time, do you need this type of time series chart prediction, or do you need this type of tip image prediction? Suppose for the future, for the 4 month, where the concentration is the high, where is the concentration is the low, I want to check it from my map. Or do you need only for this time series chart? Suppose I just make the time series chart December, but I want to forecast it for the next year. Which your need?
Okay, so for I guess if we can do the chart.
Yes. Okay, for the
So yeah, it will be better. Like just give them like a dashboard about the forecast. So when we are coming to the forecast, it will be better if they have a dashboard.
Okay, so for that, I think we can easily do it. Basically, for the forecasting, we can use here the different types of method. Suppose if I have a data set, suppose I generate the time series chart for this study area as a time series chart. Suppose this time series chart I generate, and further using this time series chart, I can easily predict the numerical value using the regression analysis. Okay, so using the regression, we can easily find out when it will be for the future 5 year or 4th year or 6th day. We can easily predict. So it's very easy way to we can easily predict. When I have a time series chart, we can easily predict. But in Google Earth Engine platform, it also some difficult when you want to make the prediction for this image. Okay, suppose where it is the in the future, where the high concentration, where is the low concentration, is very difficult to do that. But for this time series chart, we can easily predict for the future using the different types of analysis, LSTM.
Okay, so for the future, we're gonna use the graphs.
Yeah, we can.
But for the current calculations, we can use the map.
Yes.
Am I right?
Yes. It's better. Yeah.
Okay, so that's perfect.
Okay, no problem. Okay, no problem. So then it's okay, no problem. And for that, we just how many maps you need to create for the only for the one region?
Okay, first of all, do you have a refinery in your country that you think that you can rely on?
Yes. Suppose I want to show this result for my study area. So just I simply import my shape file. Or if I suppose I show the result, just simply import my shape file.
Can you select like another refinery or implement it in another refinery? Just to change the parameters, I mean.
Another means which parameter you want to need.
Maybe if you can look for something called Yamba Refinery, which is located in Saudi Arabia.
Okay, so just I simply imported the whole Saudi Arabia. Okay, whole Saudi Arabia to check. So just let me import it your Saudi Arabia boundary shape file. Just I simply
Okay.
now just so now we can get this result for this Saudi Arabia, and it look like that. So I just simply stressing the data from here. Suppose click on here, and then simply stress 98%. Then we can get the better visualization, the concentration, and then check it. Suppose apply. Now, okay, now we can get the better result. So in this time here, you can see this type of red color. Okay, so this type of red color identify about that high concentration of carbon monoxide for this study area. Okay, you can get this type of region. It's a high concentration. And if you to check how much mole, simply click on it and click on here. You can see it show the result about that 0.035 mole carbon dioxide monoxide gas is emitted. 0.353.
Okay.
Okay. And also
I think it's red because it's like high emission, right?
yeah, high emission. Red is identify high emission, and this black you can see basically it's a sequence. Suppose low is red color. I show that with the less than high emission. Okay. Then also it's also low emission. Then low. Also this low, and black is the very low. Okay, it's the lowest emission, and it show about that highest emission of carbon monoxide.
And can we add like the numbers, maybe of the emissions above the map, or it will be difficult?
So time series chart.
Yes.
Okay, so for this time series,
Okay.
so
Okay.
this time it show about the value. Suppose a specific coordinate, what is the value about that we can get from here? Just click on here, I can get this value. What is the value about that? Or if you want, suppose this time period mainly it will be show the first to mainly 11th, only 10 days data. Okay, it show about only for the 10 days emission of carbon monoxide for the Saudi Arabia region. So further, you can easily make this time series chart between this time period when the high concentration, low concentration, we can easily get make the time series chart. And when we can get the time series chart, we can easily predict this time series chart. We can easily predict using the regression and show the value for the past 10 or past one month or 2 month. What's the happened or what's the value we can get from here? Yeah, we can easily get.
Okay, and can we maybe like have the picture on specific location. I'm gonna send to you in the chat.
Okay, no problem. We can easily do it. So you can send me this specific coordinate value, or you can send me.
Yeah, just let me write. Okay, balance 10. So this one maybe.
Okay, so let me search on here. Okay, so what's the place name? Yeah, this is, yeah, Ras Tanuri,
Yes.
Saudi Arabia. So now we can get, you can see. Okay. So you can see this region is show about the high emission region. Okay, because I think for this reason a lot of biomass burning, such as kerosene or diesel or other things, the highest burning for this area.
Yes, yes.
So that's how you can get this type of things you can see. And this data show about the 2019. We can easily get this data for a specific time. Suppose you can see this data set, what is the present time. This present time, we suppose for the present time we can check it. So we can easily put here this specific time period and then check it, what is the condition. And if you want, suppose you need the only for this specific boundary, so you can simply select your study area. Suppose this is your study area, this is your study area. Just you want to work with this study area and then make the map of concentration map, as well as you also make the time series chart. Okay, no problem. Just use this. Suppose this is my study area. I simply choose, and then further I simply just put here RY.
Can we like have it on a specific building maybe?
Okay, building maybe. Okay, so in this time, this data set, mainly this resolution is the one. Mainly, you can see the resolution first. This resolution is mainly 1100. Okay, so 1100 mainly 100 into 100 square kilometer. Okay, 100 into 100 square kilometer. So that's why this data set is pixel is very high. So that's why is not find out for a specific building what's the condition of the gases. It's not possible because this pixel is very high, mainly 100 into 100 square meter. Okay, so this is another problem. But if you want, you can also check it. Suppose click on the satellite, and it covered this study area. And further we can easily get, suppose, got it. You can get this type of things when I just simply click on here and stressing the data. Then we are to get the better visualization and apply. So now we can get from here. You can see things is the high red color identify about the high emission of the carbon monoxide. Okay, I think it's some building, or I know what's that. You can see. And basically when you want to trace the building, it's very difficult because this resolution is 1000 square meter, this data set. So that's why for the big region it's easy way we can easily do it. Yeah, for the better result I can get for the big region, but small region it's not possible because this data set extract the information from 1000 meter square area.
Yeah, okay, it's clear. Yeah, it's clear.
Okay.
Okay, and let's say as you okay, for this it's clear now for the first part. The second part, which is the prediction, which gonna like, can you know which components that you use to create this emission, or still be difficult?
Yes. So for that, we are just use here the regression method. Suppose for the past time, I have a past time series. Okay, and this past based on the past time series data, I want to make the prediction. Okay. Suppose I have
Yes.
total 3 years data set for the past time for this specific area. What is the emission? So then I just apply the regression method, and using the regression we can easily predict. Mainly it's very easy way we can do it for this. Suppose I have a time series data set. Suppose you can see regression. Mainly I'll show you that.
Yeah, because sometimes they say that it's a confidential data, we cannot share
Yeah.
it. So maybe we can use like Vimy data.
Yeah. So basically in this time we are just apply this formula regression, and for this regression we can easily generate, and then building the regression model, and then we can easily find predict for the future what is the condition for that for the past 5 years or 10 years or this type of things. We can do it, no problem.
Okay, but you can. This is for the prediction, is fine. But I mean, can we tell like you have to use component CO2 with NO2 or something like the specific components for this emission? This is what I'm trying to like. Let's say okay, we have this area have the highest or has the highest emission.
Yes.
So our recommendation that because you has the highest emissions, you use maybe CO2, you use diesel, you are using fuel, you can use those components instead to not having this high emission again. Is it clear or?
Yeah, I understand about that. But in this time it's not possible. Suppose this emission is come from the diesel or kerosene or other sources, but overall it this result mainly this result show you overall all of those biomass burning. Okay, all of those biomass burning, it including the diesel, it including the kerosene, it including the other biomass burning factors. Okay, and then create this type of things from here. Okay, so from here we are just make the time series chart, and suppose when I can get the past time series chart, then I just make the regression analysis and then make the analysis. Okay.
Yeah, okay, it's clear. Just if we're gonna have the formula to calculate the chemicals, okay, and we know specific product, like okay, this refinery gonna create diesel, kerosene, and those things.
Yes.
So in the prediction side, okay, let's not talk about the current calculation of the emissions or the forecast for the next years. We are talking about the prediction, like the recommendations thing.
Yes.
So can you do a side thing for us, like adding to this model? Like for the naphtha, you can maybe blend it with this component, and you can have less emission than the usual.
Yes.
Because we know that refinery is doing like specific product. So can we utilize this information to maybe recommend some blending process than others?
Yes, we can also do it. Yeah.
So for maybe if we can take the naphtha as an example, how you are planning like to recommend the production process for like, okay, let's make it simple. We want to tell the proponents that okay, for naphtha you can use this way to predict it than the other ways, because this way will have another also will have a less emissions than the other. This is what I'm trying to get, like telling them how they can produce naphtha with less carbon.
Yeah. So in this time for that I think you can when you use this image we can get only for that overall all of those gases, all of those biomass burning gases. Okay, and when you want to make this prediction we are just use the regression model, then we can easily predict for the future what what's the value we can get from here, or how much value increase for the carbon monoxide emission.
And can you say it again? Sorry, I didn't get it.
So in this time, suppose when you want to use the data set, this data set provide you overall all of those biomass burning source emission of carbon monoxide. Okay, and then,
Okay, and including even the products, right? Like the naphtha, the jet fuel.
everything is including in here. everything in including.
Okay.
So for that, then when
Okay.
you make this time series chart, we can get the overall. Okay. Suppose for this region, every time we can get that 5 mole emission of carbon monoxide. Okay. So then using this data, past data, we try to make the future forecast. What is the happen for the future?
I'm not talking about what's happening in the future. Okay, we are done with the calculating the current footprint or the carbon emission and then forecast. We are done with this part. What I'm talking about, if we can give them a recommendation in their daily operations, because we have a data set including all the parameters, and if we can utilize this data set to tell them that you have to reduce naphtha in that way rather than the other.
Yeah, this data set is the updating daily. Yes, this data set
Yeah,
is
so
the
what I'm trying to say, yes, okay, not forecasting, it's just giving them recommendations for their daily operations.
yes, daily operation. Okay, this data set
Yes,
provide you
so
the daily operation you can get, and this data set is the updating. Suppose you can check it. Suppose I show you the data set from here. 5, and this data set we can get from year of 2018. Carbon monoxide. Yeah, so you can see we can get the data set. This is the present time, 2024, 10 February. Okay, so now it will be updating. Okay, now today is the 14th February. We can get the data at least 10 February, and it also show about the time about that. Okay, so it's updating automatically, no problem. We can easily get the update data set from here for the present time.
and how are we gonna give them the recommendations for their daily operations?
Okay, so in this time for the daily operation, this data set is not perfect. Okay, this data set, okay, so this data set also provide the daily. Suppose when you want make this data set, we can get the time series chart look like that. Okay, let me share you a time series chart. Then it is so better. So just I show you a. Just a minute. I share a time series chart. Okay, so let me share.
Also, one question: do you know any chemical people or people that knowing the chemical side of the calculations of carbon emission?
So it's the physically or remote sensing.
Yeah, let me show you. Okay, I'm not sure that I can share the screen.
Okay, let me. I can try here.
Okay, just a minute. I will try to find the document. Um, so unfortunately, I couldn't find the document, but I'm going to show you something that's similar.
Okay,
Can
can
you
you
see my screen?
Not yet.
What now? Okay. Okay, now?
Yeah, so if you're, yeah.
Okay, so it's something like this, that you're gonna have numbers about the distance, the weight of the emissions factors, the direct emissions and indirect emissions, and so on. But for this, we need someone that having, let's say, background in the chemical field, and I can share with you and also in WhatsApp like a formula we found with a lot of algebra thing.
Yeah.
But we need like someone from chemical field know about the component itself, like the naphtha, the diesel, who could also support us in this. So we can have like the chemical side of the solution and also the technical side as well. But
Okay.
you know what's our problem? The problem that we have to find someone within 2 days or something. So like we are running out of time.
Yes.
Yeah, so this is so do you know someone relative or maybe a friend or something that could help us?
Okay, so I will let you later about that after talking about them and tell you later.
Okay. And now let's come back to the solution. Yeah, you were discuss something with me. Can you share your screen?
Yeah, let's do. Okay, so when you want to work with the time series chart, suppose here you can see that this is a time series chart. We can get the data as a daily. You can see daily. Suppose you can see this the data, daily data we can get from here, and we can get the two-time data. You can see one time is showing about the specific time. Suppose 5 hours 29 minutes 23 second. We can get the data, and we can see the same date, same day. This is the another time 7 hours 10 minute 53 second. We can get the data. Okay, so it is a daily. Also you can see the second in the, you can see sometime it show the null, there is the no data. It means that in this for the other time that the not any extraction or any emission is not captured by this satellite. Okay, it's captured the satellite for this time. Okay, it's the time wise data. Also you can see the second January, we can get this time about this data. Okay, also you can see that it's the 3rd January, we can get this data. So it's a daily or daily data we can get. When you make the time series chart, we can get the daily data with the time when the satellite capture. When the satellite capture, it also show about the time and also date. Okay, for the 1 day average we can get from here. It provide the 1 day's average.
Okay. Okay. Then we have another approach just to make it specific on the refinery itself.
Yeah.
We already have the formula to calculate the emission for the refinery itself. So if we have like the emission for the total area, like the refinery and the things around the refinery, we can maybe distribute, let's say, take the total emission for the whole area and then distribute it from the emission that from the refinery itself.
Yes.
So maybe this we can have like a clear ideas, because if we're gonna tell them like, you know what, we have the emission for the city itself, they will be like, okay, but the city have cars, other refineries, why do I care about them?
Yeah.
You know? Yeah, so if we can have like the total minus the specific emission for that building, maybe it's gonna be a better idea.
Yeah.
Okay, the other thing that's related on the data, as I told you, if we can like specify the recommendations for the production itself. So do you have any data set that support the details maybe about the naphtha and how it's produced and how we can reduce it or provide recommendation to the production?
Okay.
In a chemical way maybe, but
It's a chemical, yeah.
yeah, but do we have like a data set that could help us in this in a technical way that maybe you can put it in the model or do something that to understand the correlation between them?
So in this time, suppose if you want to also check about that carbon storage, suppose if there are any trees or anything for the study area, suppose you can see it show about the high concentration. Okay, but you want to check if there is the no trees or other things. Okay, so if there is the trees are available, then this type of carbon consumption by the trees, and it also reduce. Suppose then it reduce. Basically, we are also use here. Suppose I'll show you the another code. It's better. Suppose carbon storage. Suppose I select this free study area. Suppose this my study area. Now we can get for this study what is the condition about the carbon storage for a specific trees or forest. And if there is no trees or no forest, then this carbon is not captured. You can see in this time we can get only this type of things. Okay, very small area. Okay, very small region you can get this type of things. Basically, in this time for the study area, you can see in this time simply zoom it. We can get the some. You can say I think it's some vegetation. Okay, you can see some cropland. Okay, some cropland. So this type of pixel, you can see the red color pixel, it stored this type of carbon. Basically, for the photosynthetics or others process, mainly they are stored the carbon. Okay, and in this time, this data set show you the simply stress it, then get the better view. How much carbon are stored by the trees. Okay, but where when you find out the for any suppose forest area or agricultural land or trees, this type of trees is better consumption of the carbon for their photosynthetic process. But where there is not much trees or not much things, then this carbon is not captured. In this time here you can see I can get this type of pixel, and basically this type of pixel cover the paddy land or crop land or trees. Suppose I click on here, then I can get about that. Suppose this region, how much carbon consumption. So here you can get this result. You can see it consumption 2.02. Okay, 2.02. This carbon stock mainly it's a kg per carbon per meter square. Okay, this is the unit about that. So this unit mainly it stored 2.02. Suppose I click on here, also you can click on here. Suppose click on here. In this we can get that how much carbon they are stored. They are stored 37. I think in this time this region has a lot of trees or lot of things. Okay, so just simply zoom. So here you can see we can get this. I think it's a you can paddy field we can get from here. So that's why this type of paddy field also consume the more carbon. Okay, and mainly this carbon they are used to make their photosynthetic process. Okay, so that's why it take the lot of carbon. But you can say other region in this time it's not show any kinds of carbon storage pixel because there is no trees. Okay, so that's why this type of carbon is not stored by any trees or any paddy field or anything. It's not captured. When you can get the more vegetation area, this type of carbon is also more storage. So this is another algorithm. So it's called the gross primary production, and mainly gross primary production trees are use the different type mainly carbon. Okay, for their photosynthesis process they use the carbon, and you can see this type of reason is a lot of trees, so that's why is the high concentration of the carbon storage. So it show the value. Suppose you can see the value 37, and what is the unit 37 kg per carbon per meter square they are using here. So this is the another way. If you want, you can also use this data set to make the relationship. And you can see there this is a totally barren land. Okay, so there is no data. So that's why you can get this type of there is no pixel. Okay, suppose you can see I think it's a crop land or other things. So just I want to check it. What is the condition about that cropland? So just I simply drag and then simply suppose this is the cropland, I think, yeah. In this time you can see just I simply click the run. So now I can get the result how much carbon is stored this type of cropland. Okay, and we can easily get this time series chart. You can see it will be work. Yeah, I can see for this carbon we can get from here. Okay, it look like that. It's a field. Okay, you can see it's a, I think it's a cropland or other things about the trees. Okay, so that's why you can get this type of things. And when you just simply click on here and then stress, then we can get the better view about that for just straight 98%. So just click to run. So now you can get this type of color. Mainly green color identify about the high consumption of the carbon. Red color identify about the low consumption of the carbon. Okay, so here we can get this type of things. And here you can see, click on here, then we can get the result. Suppose click on here, this trees or this paddy land consume 9.25 kg carbon per meter square. Okay, so it is another way to consumption of carbon by trees. Okay, and where there is the no trees, it shows totally blank. There is the no pixel because there is no consumption of carbon.
Okay, so if there's no consumption of carbon, that means their daily operation at that day was like the great thing to save.
Yes. And if you have to check it,
Is
suppose
it the idea?
if you want, you can also compare the data set. Suppose, here is it. Okay, so I have sorry delete that. Suppose you want to check about that. Suppose you take the same study area, and this study area you want to
Okay,
apply
just
the
one thing.
carbon.
I can see that. Sorry for the interruption, but one thing I can see that in your result, the GBP is 9.25, right?
Yes.
That you highlighted in yellow, blue. And do you know that the formula for this, like the calculation itself,
In this time we
the
are just
algebra for
okay. So
this?
in this time we are just applying in here mainly gross primary production and net primary production. Okay, so mainly gross primary production divided by net primary production, and we are using at this, you can see gross primary productivity 8 days data set, and mainly this data set input the models to calculate the terrestrial energy, mainly carbon, water cycle process or biochemistry of the vegetation. Okay, for the vegetation how much carbon will be stored, or how much water cycle they need, how much energy. So this type of things it calculated, and you can see the algorithm about that algorithm and theoretical basis document. So you can check about the algorithm. Then we are also get the lot of equation, lot of things they are used in here and create this data set. You can see the mode is daily
Yeah,
photosynthetics
because
and annual net primary productivity. So this is a data set, and the mode is daily photosynthesis data set, and we can easily get a lot of information about this data set, how it will be work and what's the product they are provide. But in this time, all of those algorithm they are include in this data set. Okay, this data set are include. So that's why you can easily use
yeah.
it, and then you can easily get the result.
Now the thing, because we need to know the calculation behind this, like the real calculation, the multiplication, the how they sum the numbers and so on. Because we need to show them evidence, like because they are chemical people.
Yes.
So we need to show them, okay,
Okay,
this
you
model
can
following
send
this
paper.
calculation. So we need to like
So you can
just a
send
kind of
them
evidence. If
yeah.
you can share, can you share those documents with me?
Okay, just I simply sharing the PDF link. This is the
Yeah,
document.
so
So
I can
basically,
share it with the.
just you try to
So this one to calculate
calculate
the
the
emission,
carbon
right?
consumption by trees. Actually, photosynthesis process, how much carbon used by vegetation. You can easily get this information using this data set. Modis, and it's provide the daily
So I can
photosynthesis.
know how much. Okay.
How
Can I know how much emission for each project, like for naphtha, diesel, kerosene, or?
yes. From that we can easily identify how much carbon is consumed by vegetation. Okay. and we can get about that. You can see the terrestrial carbon dioxide balance, as well as the carbon flux, also high interest in the global climate. So there are a lot of things in the theoretical part of the background of this data set. You can see. Okay.
Yes, yes, that's clear. Okay, so coming to the solution, just can we summarize with the three things? For the calculation, like for the footprint, can you use something that will be specific this on the site? Like this one. I really like this one because you can zoom in as much as you can and you can like indicate a specific area.
Yeah.
So can you use this for the calculation or it will not work?
This one.
Yes, the one that don't need pixels.
Hello.
Yes, yes, I'm hearing.
Okay. So do you have any
So
question?
yeah, I was asking if we can use it. Like this one currently for the carbon consumption, I think. But
Yeah.
can we use it for the carbon calculation as well? Is
Yes.
it the same?
Yes, we can also use the carbon. You can see basically in this time it also show the time series chart about that. You can see for that how much carbon use on the different time. We can get that. You can see 5th March 11th kg carbon per meter square. Also you can see that it's also high about that. February 28.74 kg carbon per meter square. We can get this value. In this time, this type of carbon is consumed by vegetation different time.
Okay. So for the forecast and
For
the
the
calculation,
forecast, for the
we are
forecast,
done.
suppose in this time, this is my time series chart. So further, we are just download the time series Excel file, and when I can get this time series chart, then I simply forecast. And suppose for you can see in this time we can get this type of data. So basically, this data set in this time we can get this type of data. I can see January. Okay. So in this time, this data set I need to suppose monthly. Suppose I just try to find out the January average value, February average value, March average value, April average value. Okay. Then I just calculate the monthly data. Okay. First, suppose January how much, February how much. Okay. So further, we are just applying the regression model. Okay, we are just convert it as a monthly or annual. Okay, then we can easily convert
Okay.
it.
And can we make like, okay, we're gonna show the map, we're gonna show the forecast, but can we show it like in a dashboard thing? So they click on a button, then a dashboard will be created according to the data that we have
Yes,
for
it's
the
also
consumption
possible.
and for the.
But okay, it's possible. Suppose in this time, you can see the chart is showing here. But if you want, you can just make some web application. So let me show you some web application which I already done. So using this web application, we can easily create this type of dashboard. Suppose
Yeah, we want something that will be professional for the managers to view, like something informative.
yeah. So let me open my gallery. Suppose you can just simply draw your study area. Suppose I just show you that. Suppose this is the another data set. It's called the leaf area index. Okay, and it's very useful data set for different types of monitoring the cropland or other things. So suppose we can get the whole area. Suppose this is my study area. Okay, so this study area I want to observe what is the condition about the leaf area index. Just I simply draw my polygon. Suppose I just draw my study area. So now you can see it automatically generating the chart as well as also show you the map about that. So here you can see it show this type of things. So and it also better when I add the legend also. So in this time we are also add the legend. So that's why anyone can easily understand what is the condition, what the value for the green or this type of thing they can easily understand. Okay, so just add a legend in here. Okay, then anyone and it automatically show you the chart. Basically, it's a time series chart. Between this time you can see it show the time series chart from here. So down click on here, then we can get this type of chart. Download the data Excel file. Okay, so it's a one kind of dashboard. So just you try to another polygon or another, just simply click on here and draw this study area, and then it automatically created for this map, and also automatically create the time series chart for a study area. We can easily get from here. It's another